Hey everyone! Thank you so much for watching another episode of the Weaviate podcast. I'm super excited to welcome David Matheu to the Weaviate podcast. David is the co-founder of VetRec, one of the most interesting pivots in my times I've seen in the in the AI startup space. We originally had Kevin Cohen on the Weaviate podcast, who took us through all sorts of technical details of Neum AI and the work they were doing with ETL. Kevin and I had met in our shared Slack channel with Weaviate, where he was working with Byron, who, if you're working with Byron at Weaviate, it means you're probably solving a pretty technical problem. So I learned so much from Kevin and David. I'm so excited to welcome you to the podcast and learn about VetRec and generally what you're up to. Thank you so much for joining.
It's great to be here, Connor. Excited to share what we're up to with everyone.
Awesome. So could we just dive right in, the pivot from Neum AI to VetRec? What's the story?
Yeah. So it is, I think, one of those interesting pivots where like they seem very unrelated, I think, on the surface level. But I think that, as we'll talk a little bit about today, like they're actually more related than I think most people kind of realize. And so back when you talked to Kevin, we were working on NeumAI. We were focused on like the ETL aspects of vector databases and vectors. We were doing embeddings at scale. I think at the time we're moving something like 1 billion embeddings or like a month or something like that. And we were focused on doing like open source stuff. We were kind of building like a lot of the tooling on from that perspective. Something that we kind of like realized as we were doing that was that a lot of the companies that we were hoping to sell to were still kind of like early, a lot of them in their journey of figuring out how to do this. And more so we saw that like at the consumer level there were all these opportunities still kind of like lying around of people wanting solutions to problems that they were having, and that like there was still kind of like somewhat of a slow movement to kind of go and solve them, as a lot of people were still kind of figuring out what to do with the technology. And so for us, like I think like we kind of reached a position where we were like, okay, like we think that we could like accelerate quickly into taking everything we know about the space and like everything we built and simply go apply it at like a vertical that we think has a high impact. And that's kind of what we've done. We ended up looking at several different verticals. We ended up choosing vets mostly because we had friends and family in the space that were talking about how much of a like a lack of technology there is within it, and a lot of the problems that they were describing sounded very similar to a lot of the problems that we knew people were already solving with RAG and with LLMs and stuff like that. And like we were able to kind of quickly accelerate and build something. And so just to kind of give you a sense of the timeline, we ended up pivoting from Neum into the vet space in less than a month. So again, like that's just how translatable kind of everything was, that we are able to go build quickly in there.
It's so exciting. I think, yeah, kind of like this RAG for like, yeah, well, I guess like RAG for any kind of information domain is such a common thing. And there's all sorts of specializations in like healthcare, lawyers, and definitely a lot of code documentation. It's a lot of the programmers working on RAG then want to do something they can wrap their heads around. And so maybe I want to, if we could zoom in a little further on the decision to pick RAG for vets, and then sort of like how you're going about the consulting, the learning about this domain. Maybe like when I first
Yeah.
heard this news, I imagined that maybe during your time at Neum AI, that a vet customer was like the biggest customer that you found, or whoever you enjoyed working with the most, and that's kind of how I would imagine that this kind of
Yeah.
startup story goes. Could you maybe help me understand further?
Yeah. I get. We can talk about that. So actually, no, we were not working with a ton of vets at the time. Vets by nature are pretty not like they're technical in their own way. They're just not technical with technology. And so a lot of the exploration that we've done into the space and like how quickly we've gotten up and running on it has been mostly through like a lot of friends and family connections that we had within the space. Like I kind of joke with people that like even though you might not realize it, you're like probably like a couple degrees away of a vet, like because everyone has a pet, or like your cousin or your aunt or your uncle or someone's a vet in your family. And so we were able to kind of quickly, like just from that perspective, learn a ton about the space. And and you're right, like within the veterinary space, like I think what we saw was like this plethora of information that these people were trying to leverage, in addition to information that was getting captured every day, because every time that they see a patient, there's just like again, like another set of information that gets continuously created. And there were several challenges that they were having around how to leverage this information in the best way possible. Um, Starting with things like note taking, and how do you go about saying, okay, like after a consultation, generating notes, generating information that we can later leverage for our own records, or to prescribe medication, or to like do our billing, like that's all information that gets captured. And then even as we are like looking now deeper, it's like, well, there's all this like also just rich information online about, and it comes a lot in the form of like encyclopedias or books, or even hit like previous history for patients. That's just like today that's not being used in a meaningful way outside of like people having to manually like go search for a history or for like an encyclopedia, and like reading through it and being like, oh, like this is what I was looking for. And so like that's where we see a lot of the potential of like, super powering kind of like what they do today with like new sources of information that can be put at their fingertips very quickly. And so far, like I think that it's for a lot of the doctors that we're working with today, it has been a bit of a night and day type moment where they're like, I didn't know that you could like have information at your fingertips so quickly, or I didn't know that you could take information and like present it in this all these different ways, because they're kind of more used to kind of like in some cases to like pen and paper, quite literally, or they're used to having to leverage systems that might be a little bit older, that don't really provide a ton of these capabilities on top of them. So for a lot of them, it has been kind of an eye-opening moment, and I think that like a lot, it'll just get more and more. It'll get better as like we continue to leverage a lot of the existing technology and tools that are out there. So.
Yeah, it inspires so much. I really like this. I read your article about speech to text and how you have correcting these transcription errors, that I think is a really interesting thing when you're talking about a specific domain. Like I like to dog food, use this podcast to search through, and even this podcast, like if we start referencing, papers or specific terms, it won't quite pick it up. And but maybe just one more kind of point on this startup thing before kind of going deeper into the vet kind of application domain, particularly. Because you have this experience with Y Combinator, and I think that's something that a lot of people listening to this podcast who are curious about building AI startups might be really curious about. Is what kind of advice do you get from Y Combinator? What kind of, when you're saying, hey, we're thinking about pivoting from Neum to VetRec, what are those conversations like?
So I think like the main advice that Y Combinator always provides is really around like failing fast. And I think that like, when we started talking about like pivoting out of like what we're doing into the vet space, I think that the feedback was what we have always heard, which is like, go prove it, and like go prove it as quickly as possible. And so that's where like, for us, our turnaround time was again like literally less than a month from going from idea to first customer. And that's like that is like the type of turnaround that you ideally want to see if you're going to try to pivot. And even if you're going to build a company, like, if you're spending more than a couple weeks building a prototype, it probably means that you over engineered too much. Sure, like, I mean, people will always say like, oh, like my idea is more complicated than that, or I'm building something that like requires more features, whatever. And that might be true in a select number of places. Like if you're building, I don't know, like a cell phone, okay, sure, like you can't like there might be more features and more manufacturing and things that you need to go do. But generally, I think with software, one of the beauties is that you can go out and build something that someone can use and test in like literally weeks. And so if you're spending more than a couple weeks building a prototype, I think that that's probably too much. And I mean, yeah, like that was the only advice we got. I was like, okay, cool, like how quickly can you prove that this is actually viable? And if it's going to take you more than a couple of weeks, you're probably looking too deep. And so
So then what does the first customer, this is a question I hear a lot from AI entrepreneurs, is like, do you put out these blog, like I know you and Kevin have written these really amazing blog posts on your lessons learned in RAG. Do you kind of use the content as a part of like an introduction message that you send to vets? How is that journey of like getting the first customer?
Yeah, so in this case, I think that finding the first customer was relatively simple, quote unquote, because we had like such a specific problem that we're trying to solve. And so we actually like our first customer was actually the same people that had told us that it was a problem in the first place. And so before we even wrote the first line of code, we kind of already knew that this was a problem, and there were people that were willing and interested to pay to have it solved. And so that was, I think, a big benefit. I think that like looking back to a lot of the stuff that we were doing kind of in the rack space, it was a little bit more where the problem was a little bit more abstract. And I think that like I don't know if you agree with that, but like, I think like the rack problem is a little bit more abstract. And so like finding that first customer is a little bit more complicated because it's like you're kind of, you don't know exactly what you're looking for. Like you're like, oh, like I'm looking for a company that's probably building AI, that's probably, but it's a lot more of a lot more of an abstract customer. In this case, it was like we purposely kind of centered on like a very specific problem with a very specific audience, and we've gone even more specific over the last couple of weeks. Like right now our ICP is like very specific of what we're looking for, and that I think like just helps because the if we had been like we're looking for someone that like needs help with like data, that's like that's so broad that like it's very hard to focus. But like if we're like, okay, we're looking for vets that have a lot of data, okay, that becomes more specific. And then now we're even like even a little bit more focused, where we're like looking for vets on certain ages, because we have found that they are more interested in the product, and we're looking for vets that see a minimum number of patients a day, because we know that like the value of the product is higher if they do that. And so like but it all starts with like getting very specific about who that customer is. And that I think has worked really well, like in that like first phase, like again, like about a month of like building the first prototype and having someone to hand it over to. It really, like, I think it worked really well from that perspective.
That's amazing. One of our earlier podcasts as well was with Jana Wellender, who does a lot of work on product managers, and she has this really forward-looking view on like how GPT-4 and all that will help you get like harness customer feedback. And see, I really want to just stay on this a little further because you're learning a totally new application domain. You have a really technical product that you also kind of have to like explain to them, I'd imagine, right? So how is this like? How do you organize? Maybe if we could even get like right into it, like do you have maybe like your notes of like each of the meetings with these potential
Yeah.
customers, and you just
So like so when we pivoted, like in a lot of ways we kind of forgot about what we have already built, because it was like kind of a necessity at the beginning, where like I think like I think like a part of like a successful pivot is also like tackling the problem from kind of like first principles again, versus like trying to like pigeonhole whatever we already had into it. And so we started kind of from square one a little bit there, where we were like, okay, like let's talk about the problem. And specifically the problem that with vets had, like the first problem we heard was really around helping them consolidate notes and helping them kind of make sense of the consultations that they're driving with people. And so namely, that started with things like speech to text, being able to kind of capture conversations, be able to bring them into a format that like the computer can now better understand, and that the large language models can understand, and that we can start to like generate insights and stuff like that around it. And a big part of it was also like understanding the workflows that these folks use, because I think that like if we had been like, hey, here's like a platform, like a generic chatbot or whatever that you can talk to, that like in hindsight, like we know a lot more now, like that would have 100% not worked, because like that's not how veterinarians like go about their day. Like they're not in front of a screen all the time. They actually try to minimize the amount of time that they're in front of a screen. They try to maximize the amount of time they're in front of the patient, how many patients they're able to see in a day, how many procedures they're able to do, because ultimately that's where their incentives are related to like their practices, and like making money and maintaining their practice up and running. And so like from that first principles perspective, we're like, okay, like it seems like the biggest problem that they want us to start with is like this concept of like, okay, like transcription and like scribing. And that's kind of like and so that was kind of the first features that we started to ship. And it's to this day kind of like the first thing that we generally will introduce vets to, because it's kind of like like you hear, I think like you hear this term a lot, like it's the wedge essentially with these folks, where like that's the true problem that they have. That's the main thing that they're struggling with. And before we can talk about these more extraordinary applications that we can do, like we need to solve kind of the main problem that they have, which is note taking. And so we understood that, and we understood the workflow that these folks have, the tools that had to be integrated into that workflow, the way that they operate within their clinics, then that allowed us to build kind of this first wedge solution that vets started to like and use every day, and that allowed us to now start talking about kind of like the next steps that we can do. And so, within our customer pool, we have, I think, like a couple cohorts within it where, we have some vets that we're just onboarding. And so for them right now, the focus is kind of like on these first wedge application stuff that we're doing. But then we also have now vets that have been on the platform for a couple months now, and that now they're starting to figure out that there's more that we can do for them. And so, for example, one of the more advanced applications that we're now doing is like we're doing things like AI generated differential diagnosis. So a differential diagnosis is essentially like the doctor has a diagnosis in mind of what's wrong with the pet, but there's usually other potential diagnoses that they might need to consider. And today, when they do differential diagnosis, it's either by memory, or they go consult with an encyclopedia to kind of like, based on the symptoms, get the right diagnosis. And so that's actually like one of the areas that where we're now starting to kind of like supercharge things, because it's like, well, what if we took that encyclopedia that you're struggling to read through every day or have to like consult over and over, and we just ingested that, and it becomes it's now a vector database that we have certain parameters on, and we're now able to go and, based on the symptoms that we're capturing, go do a search on it and say, hey, based on these 4 or 5 symptoms that we have of from this patient, like give me the highest the highest relevancy results out of that encyclopedia. But like I think that I think part of like what I'm trying to get to is like the idea that to get to that point, we kind of have to understand kind of like what their workflows look like, so that then now we're now starting to apply kind of these more advanced like use cases that I think are ultimately going to be the most interesting, and I think it'll blow people's minds as they see them kind of up and running. But we have to kind of solve like the main problem first, which is like more related to, again, like note taking, more to how they drive consultations, how they start integrating their workflows.
Well, I'd love to stay on note taking a little more before coming into the differential diagnosis, because I think this kind of identifying the workflow, and I have to quickly plug DSPy because I'm a huge fan of it, and the podcast has to mention it. But it's something, is a tool that really helps me think about like coding these workflows, and then really optimizing the task descriptions and examples to make the LLMs perform the workflow well. And so also selfishly, I do this kind of transcribe this podcast, and I also have this problem of like these little errors like Weaviate. It might translate that into like, WV8 and things like this. So I'd love to just brainstorm on how we solve this problem. Something I've started doing is I hook it up with the U search engine. I really, because I think you need kind of like web search, because these podcasts, like you and I are going to discuss soap notes, right? And I don't have that in my private index, so I need the retrieval. So how are you taking down that problem of solving transcription errors?
Yeah, so we've been kind of like making our pipeline more and more complex. But at the beginning, we were doing things like passing literally the transcripts back back through like LLM models, and I think that like that's the easiest thing you can do to try to like see if there's any things that were wrong, or that we might have missed, or we got the wrong words at. One thing that we did find is that by doing that, the results were a little bit better. But in a lot of ways, it was adding latency in a way that like the doctors were not very happy with, because I think like a lot of the expectation within what we're doing is like, we have about 60 seconds or so to go from transcript to notes, for them to kind of like not like churn off the product, essentially, because like the longer we take, the more they're waiting for the notes, etc. And so we found that was adding a little bit too much latency in some cases. And so now what we're doing is we're actually like doing more of like a combined step where as we're extracting information out of the notes, we're also doing some comparisons in order to try to match words and be able to fix any wording issues that were detected. We still, I think, have a lot of work to do on like making sure that continues to be better. We also have, I think, increasingly asks around making sure that we have like custom vocabularies and stuff like that, depending on who the vet is and the specialty that they represent, etc. But we've started to try to make that more modular so that we can plug in those custom vocabulary dictionaries and be able to again in that combined step where we're start extracting data to start generating notes for. We're also doing some of those fixes and making sure that we're inserting the right words. A lot of that, today it's a little bit more brute force what we're doing. I think that we envision that some of that will transition over to either using RAG, for example, to try to like distill the dictionaries down, or start to even plug in some of the more advanced like resources that we have. Like in the case of veterinary medicine, we have encyclopedias that are kind of like the holy bible of everything. So like they're a little bit of like a catch-all resource for us. And so we're starting to plug those in here and there. But I think that there's still kind of work for us to optimize those workflows. And again, I think like the main thing that we're dealing with is this like latency problem where like, if I could take 10 minutes to process the notes, it means that, I could do I could do a lot more fancier stuff. I could like pass it back and forth between models. I could like search, like do web search or like, but I think that the reality is that in a lot of ways the amount of time that we have is actually quite limited. And so we're having to be kind of like smart about where are we plugging things in? How are we like combining steps if possible? As well as like, we're also doing a ton of parallelization where possible so that we're able to kind of like run as many steps as possible kind of at the same time and then like start merging them back together. And so we've done some interesting stuff around that. I'm curious, like if those are some of the techniques that you're using as well, or if there's anything that we should look for. Like, always down for feedback or advice on since you're the expert. Yeah.
When I spoke with Kevin, he had taught me a ton about distributed messaging queues, and then sort of, I don't know if I'm sharing too much about me, but like then I joined the research team at Weaviate, and I learned a lot more about like multi-threading from Abdel, and so I'm sure that you are up to some crazy stuff with the parallelization of the programs and that whole like running processes in parallel, having fault tolerance for some kind of like part whole hierarchy, locking, all that good stuff. I'm sure there's
the way like there's also kind of a balance because we've also reached points where we're over parallelizing things, and that leads to like a decrease in context across the models. And so like I think like that's something that people like. I think people love to talk about like large context windows and stuff like that on the models, and I think that like I'm more of the camp where like I actually don't really care about the context windows because like generally they don't perform well, and even if the performance got better, like I think that like in a lot of ways I rather have like more specific workflows than like just a very generic one. And I think that's very much kind of like the school that I think you guys at Weaviate also kind of adhere to. And so for us, like I think like we've been trying to kind of like hit that balance of like how much parallelization can we do before the model starts to lose context, but also how do we still kind of like keep these like workflows to be pretty anatomic and like smaller units that we can kind of play around and be able to change the order of operation of things wherever we need. And again, like with kind of the ultimate goal being like, how do we do this as fast as possible while keeping the quality up? And so, when we started working on this, I think we were like, it took like 3 minutes or something like that to generate a set of notes out of like a 1 hour conversation. Right now we're about 60 seconds or so, which like might seem like an amazing, but I think we still have a lot of work to do to get it down to 30 seconds or so, which I think will be kind of the sweet spot. And yeah, I think that like most of the work there is going to just be related to how are we continuing to do either parallelization of some of these processes, as well as just like being able to ensure that we analyze how deep are we going and making sure that we're not reducing quality by or losing context by going to an atomic zone.
Hmm. Yeah, it's such an interesting topic. I definitely kind of wanted to pick your brain about some of the ETL stuff and the LLMs, and I think sort of like in sort of like DSPy land, we like to call it like a program, like an LLM program. But I think workflow, I think like workflow equals program, same kind of abstraction. And hopefully, with this podcast, people are understanding that sort of parallelizing parts of your program workflow. This is like table stakes to speeding it up and unlocking these, low latency applications.
It's yeah, I also think that it like forces you to again to like break your workflow to be like as like smaller units. Again, like I have nothing against people that have like these like insanely large like context windows that they just like throw in. But I think that at least in our experience, we've seen much better results whenever we break it apart and bring it down. And I think that like in our case, I think latency has been kind of the driver to get us to like do a lot of these things and like push harder on that direction. But I think that ultimately the quality of the program is also increasing by doing this, because I think that like if you're banking on like I don't know, like if sending in like just to give you kind of like an example, like a 1 hour transcript is somewhere in the range of like 16,000 tokens, which like sure, like it like I could throw it into like a 16K window and it's fine. But the reality is that like I mean 16K tokens, you're losing a lot of you might lose a lot of quality just if you're not separating it out. And so that's where I think like even though latency was kind of the main driver for us to start breaking things apart, I do think that the quality has also been going up, because now with a lot of the parallelization that we're doing, we have no concerns on having to run a bunch of prompts, which I think is something people are scared of, because it's like, oh, like I get like increasing amounts of time per process, and in our case, it's just like it doesn't matter because we're parallelizing everything either way, and so it's gonna take as long as the largest one.
Yeah, super
But
interesting. I maybe we could even keep this on sort of the differential diagnosis kind of thinking. I imagine like I have a dog and I've taken her to the vet and I waited too long to introduce Bowen. But anyway, so I've seen this kind of I can definitely imagine how you're telling the vet about how how her walks, how her poops have been, and they weigh her and then they maybe come up with the we propose these tests for you, here's what the bill is going to be. And it's like I'm very curious about this idea of like maybe it retrieves from like all the literature
Mhm.
published, and so it's like this super connected system of like here are possible treatment plans, here's like potential risks for her and
Yeah.
stuff like this. Yeah.
Yeah, so that's I think a big part. Like, and I think like, and again we've been kind of careful of like how we've rolled some of this stuff out, because like at the end of the day, we don't want to freak them out either. Like we also like know that like they they have their own perspectives, and they're technical in their domain, and so like we don't want to impose and say like we think we're right and you're wrong, or like we think that this. And so we've been kind of careful about how we're navigating that. But yeah, like I think at a high level, like being able to extract from all that literature and come out and say, hey, we found some references that maybe support what you're saying, or here are some other options that we think you might want to consider, and here are the reasons why. um, I do think becomes pretty powerful, and a lot of that is gonna, again, it'll need to be powered by something like RAG, just because we're having to take entire encyclopedias, entire like repositories of articles or like papers, and having to ingest that in a way that we can search for it very quickly. Again, like I think that with the importance of latency that we have, it also does mean that we cannot be like super we can't be searching on in real time. We cannot be like passing in or doing like a ton of like agentic stuff, like where you might have like thought process, because like all of that takes time. And so we have to do as much of that pre-processing as possible beforehand, get the data into a format that's like ready to consume. And a lot of that, I think, again, is going to be, well, it's already starting to be powered by RAG. And I think like we're going to keep doubling down on our ability to make sure that those workflows are like very snappy, very fast, but also bring in all this context in a way that the models can leverage it and provide the best answers possible.
Yeah, I think there's so much in that. Maybe first thing on that agentic thought process thing, it's like, yeah, I with when I'm designing these workflow programs, like there's always you could always like kind of keep looping. There's always like that kind of option,
Yeah.
and
Yes. Yeah. Like I think like that has like it's something that we have kind of stayed away from again because I think that like because of the type of audience that we're building for and the type of latency that they're expecting, if I'm building like a developer tool, like let's say like Devin, like that came out
oh
yesterday,
yeah,
that
yeah,
like and for a dev, it probably is interesting to see the in between steps. It's like, hey, okay, you're looking for this, and like you're doing this, and you're doing pip install for something, and you're like that's I think that like for a dev that's interesting to see. I think that like when based on like our persona, like vets, like it's like they're not super interested in like how we got to the answer. They just care about that the answer is correct and it's there. They do care about things like references, for example, but they might not sit around for 10 minutes while the model is like searching online and like pulling reference like that's just not something that they like we have found too much interest on. And so that is where I think like in many ways we're trying to move a lot of that like agentic type of thinking out into the pre-processing step of the data. And I've always like even back from the Neum days, I was a big proponent around pre-processing all the time because it was just like you know when would you rather like do the processing of the data? Would you rather do it when there's no pressure or time crunch, or do you rather do it like right before you're about to serve it? Um, yeah, we're trying to do a lot of that pre-processing before we are using like agents and things like that as part of that pre-processing to help us either find data or try to like clean up sources that we have. But ultimately, like all of that needs to happen beforehand so that at the time of the doctor coming in and saying like, okay, here's the consultation, give me the notes, or give me differential diagnosis for this, or give me patient like educational material, like all these things that we're doing, like we can't be like, hold on, we're gonna like go do the search now. And so
yeah.
uh yeah.
Fascinating. I guess I've sort of fallen in love with the intermediate reasoning steps being a part of kind of the user interface design, but I can hear that maybe that is like a programmer who's written the program and wants to see their program.
Yeah, like I think like in their case, like we just have not found like necessarily interest in that. And again, like I think that this is where like going to part of our initial part of the conversation, it's like it all depends on who are you building for. And like I think that like if you try to build something for a certain audience and you try to apply the same model that works for devs, like it's probably not going to work for them. um that also like, and I don't know how much you want to talk about this, but like we that also kind of applies to like the interface itself, where I think that like chat interfaces have been the number one thing that most people like use for an LLM. And in the case of doctors, it's like they don't have time to chat with this thing. Like the interface, the workflow is completely different. They're like there's no need for a chatbot. And so that is also like a place where like we have built our interface to be like very specific, very tailored from that perspective. And I think like it's part of what like folks that might be interested in like building for some of these like different audiences might want to think about. That's like not everything is solved with like a chat box. I think so.
Yeah, that's one of the biggest kind of emphasis at Weaviate, I'd say right now, is sort of beyond RAG and into we like to call these kind of things generative feedback loops to broadly describe like output of a generative model saved back in a database. Like if you transcribe it and then you convert it into a SOAP note and then you save that SOAP note because later on you want to use the SOAP note to like retrieve from medical literature and propose a diagnosis plan and all this kind of stuff. And so yeah, that kind of thinking of what can we generate beyond just chatbots, also so super interesting, of this user interface design, human AI interaction, all that. So David, a question I really wanted to ask you about is, your thoughts. We've already kind of touched on it, but like the whole like kind of ETL space. We see players like Unstructured, or say LlamaIndex has LlamaParse, and
Right. I'm like, I get in trouble with the answer. No, I'm kidding. No, yeah. So I think that like, I mean, I still see like a big need around in that space, and I think that like, the reality is that like there is going to be need for tools there. I do think like the part that for us, like I think was also one of the reasons that we kind of like decided to look more vertical was that we felt like most companies, and what I mean companies like customers, like people that would use these tools or use these things, they still feel like they're in kind of like an experimentation phase as well. And so even though um, there are all these potential techniques and all these potential like like possibilities of how people might use these things, I think that like it's still kind of yet to be seen what are the things that are gonna stick and what are the things that like at the end of the day people are not gonna use. And I think that like from that perspective, if like as a vector database, for example, we like that's always going to be a part of the pie. But then if you're building like a tool that's like specifically doing, I don't know, like re-ranking, like it's still like I think a very much an open question in my head of like, is re-ranking going to be part of the stack a year from now? Like, is it like, I think like the answer might be yes, like everyone's going to have a re-ranker, but the answer might also be like, no, actually, like the models have gotten so good that you just kind of like give them all your data and they like automatically do some of the re-ranking themselves, and there's no need for like your own re-ranker. Um, so like I think that like that's where like, and that's an example, but I think that like it's sort of true across like a lot of those different developments where there's kind of still this open question of like what is going to stick, what's not going to stick. I do think that like looking at the space, like for example folks like Unstructured, like taking like a much deeper focus on things like chunking seem like that seems like the right move, because I think that like again I think chunking might be one of those things that I could see being part of that like core stack. Like you're gonna need some type of way of breaking apart your documentation, so that feels like a core component of that ETL. Um, and so, but I think like ultimately it really depends on like finding those things that are truly necessary and that are going to be around in a year. And like I think that was the part that for us it was still kind of hard to figure out like what parts of what we were building actually were going to be around for a year versus things that people are maybe just like testing with or like thinking about, and that ultimately once they figure out how to solve their problem might not be necessary or required.
yeah, I think that's a great perspective on it overall. I love the example with re-ranking. Is a perfect like one of those. Is it gonna persist?
Yeah, I mean, and I think you could do it. You could say it with everything. I think like the other trend that we generally I think saw from a lot of customers is that there's still kind of a bit of an apprehension for folks to like, especially if you're building like an ETL framework type thing. Like I think that there is some apprehension from developers in a lot of ways to adopt these. I think like within a lot of companies they're building kind of their own, and like they're building it to be specific to their use case. Is that gonna fly a year from now? I actually don't know, because again like I think it's the type of thing where if you're in an experimentation stage, doing something yourself is probably enough. You might not go rebuild your a vector database because that's like a lot more work, but like building like a pipeline seems a lot more feasible to do if you're like if you have data engineers and like people on your team that have that knowledge, which I think most enterprises have and a lot of like serious customers have. And so like, but I think like a year from now, it's also I think the question of like are these companies gonna suddenly want to go buy essentially solutions that maybe do something similar to what they're doing like internally, and the buy decision might be related to the fact that these platforms do more, maybe they have better techniques, they have consolidated kind of like some key capabilities that they might have not been able to replicate internally. And like again, like, I think that that's where like for example like coming back to Unstructured, I think like what they're doing with like chunking and with loading again feels like those types of capabilities where like building your own PDF loader that's really 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 good is like really really hard to do. And so like okay, like I could see like companies being like, oh, like we built like someone with like PyPDF to get started, and then we kind of got to a point where like it no longer scales to what we want to do, or this use case that doesn't work for it, so we're gonna go buy. Um, and so I think like that specialization, I think, is what's gonna lead to some of that like buy decisions from companies where they're gonna be like, okay, the basic pipeline we set up internally is no longer working. Let's go think about what could we do that's more reliable, that's more robust, that it has better performance and kind of like different specific loaders, different specific things. And I think that that's where like the opportunity will lie for some of these folks. And I think it'll be interesting to see how they evolve with it.
Yeah, that inspires so much thinking for me. I mean, the kind of the OCR, the kind of, we have a special model for parsing PDFs, and like kind of a funny thing when I've spoken to people from Unstructured, I don't know if I can say this on the podcast, but they'll be like the work is so tedious, like it's such a painstaking thing to do, and I think it's interesting that kind of thinking about startup strategy is go find a problem that's just so irritating to solve, and then
Yeah. Well, because I think like part of the reality, and this is like something we heard a ton from companies whenever we were selling Neum, or even companies that we're working with. It's like data work in the past, and I don't want to generalize, but it was like an unsexy thing. If you were put on like the data project on your team, you're like, fuck, like I want to be building like iOS apps, or like I want to be like the guy that's like building the distributed systems. Like, why am I like the one cleaning data? And I think that like suddenly, like in the last year, it became kind of the sexiest thing now that you could do. Like if you were told by your manager, like, you're the one who's gonna clean up the data for like our LLM project, you're like, hell yes, like best news I've gotten. And so I do think like, and so I think that shift is also, I think, informing a lot of like what's driving that like tedious versus non-tedious things right now. It might be that we get back to kind of the old days at some point where people are like actually everything related to data is really tedious, which it kind of is. And we're back to like wanting other people to do it. And I think like what you said is like, I think like spot on. It's just like, if you're looking to build in the ETL space as a startup, I think that like the more specific you get with what the tedious problem is, I think like the better. And I think like, in hindsight for us at Neum, I think that was when we were building Neum, I think that was probably one of the things that we didn't do as good of a job as we could have, of just like finding that like specific like super tedious task. I think we were trying to be a little bit more generalized in terms of our approach, and like at the end of the day, I think it was like no, like people probably don't want a pipeline. What they want is like a really good loader for PDFs because it's a pain in the ass. And I actually have like a funny like anecdote about this because like as we were starting Neum like back in June, I one of the things that we were doing for customers was we were actually like doing loaders for CSV files. Which again, like it might sound like this like super basic thing. Again, CSVs are way simpler than PDFs, but like people were having a lot of trouble with CSVs. And to this day, like we published one of the very first articles we published as Neum was about like how to like ingest spreadsheets. And to this day, it's probably like has probably the highest views out of any of the articles that we did. Even some of the Hacker News, like that one was really high, like in terms of like views and people interest. And one of the things like I was doing for a while was like I remember like one day going into the LangChain like repo, and there was this issue that someone had opened being like I need a better CSV loader, and so I copy pasted like our open source code for it. I was like, hey, here's like our loader, like if you're interested. And to this day, it has like like it has a bunch of upvotes. Like people still like 6 months later, people are still commenting on that issue, being like, oh my god, finally a loader. And so I think it just like shows you like I think like the fact that like it's not about like maybe building like the shiny thing that's like, oh, like it's a shiny pipeline that like does everything. And it's more like, oh, you built a CSV loader that actually works, and it's like, oh, like that is like 90% of the problem that most of these companies are trying, the problem that they actually have, because the pipeline itself, they can go build it. It's nothing. It's not rocket science to go build a pipeline for data. But like some of these transformations that might be unique or new to the space, I think that's where people are having issues. And again, like that's where, again, like not to like overly harp on like what Unstructured is doing, but I think that like they're focused on like saying we're just going to be like a really good loader and we're going to be a really good chunker, and like sure there's like an ETL component to it, but like the pieces by themselves like work. It's like I think that that's kind of like important, especially right now, because I think that that's where companies are going to be finding the value, not in like again here's like a bright shiny thing that tries to do everything but maybe doesn't do everything as well.
Yeah, it's such an interesting point. Just kind of like, yeah, having that load from CSV, kind of like the pandas, and but then into the vector database, and just making that easier.
Yeah, like to me it's still kind of bizarre like how popular that post got, and how like I literally had someone ping me on Reddit, because I also had published this on Reddit, and I had someone ping me like last week being like, thank you so much, you saved my job, because I was struggling for a month on this and I literally copied your code and it worked. And I was like, seriously? What? Like really? That's the part that like you were impressed by? It's like again I think it just like I think it talks to just like I think like the fact that there's kind of these like very specific problems that people are trying to solve, whether it is like again us solving things for veterinarians or someone solving something for a dev. It's like I think it's like there's some of these like super specific problems, and you don't need to go solve the full thing to solve them. Like again, you could build like a CSV loader that actually works and people are actually like impressed by it, which like again it's just like a little bit to me it's been amusing to see, and like at least once a month I get a message about it. Everyone's like, oh, thank you so much for posting it. It's like seriously, that's the part you were impressed by. We did so much other work, but that's the part. Okay, that's fine.
Awesome. I want to dive into this one. So this is going to be a pretty big topic, and maybe we'll anchor it. This will be our last like deep dive into something, but because I'm really curious about one opportunity I see for ETL is you're parsing a PDF for the sake of extracting
Mhm.
chunks for vector databases, tuples for say knowledge graphs, as well as maybe aligning it with symbolic metadata that is maybe in some kind of SQL schema, like maybe like CSV columns, or potentially there's more structure to it. And so that was always something that really interested me when Kevin was teaching me about the distributed messaging queue and how you kind of retain like we're all of us chunks are a part of the same PDF, right? And so you
Yeah.
kind of can also get that metadata about the whole PDF. And so I'm just curious, like I imagine with vets and soap notes, you're interpreting tables as well. And so I see these three kind of categories of data retrieval, like vector search, maybe knowledge graph tuple retrieval, like it's very factual, and then also this kind of symbolic metadata. And then I think ETL, how you parse data to populate those three data
Hmm.
systems, is a huge one. How do you think
Yeah.
about that topic?
Yeah, that's interesting. So I do think that like the way that we had approached this problem and the way that we're kind of thinking about it now, it really starts with like understanding like I do think it kind of starts at the metadata level, and the reason I think it starts at the metadata is because um, I think that the metadata in a lot of ways kind of like defines what the purpose of the data is going to be. Like it defines a lot of the filters that you're likely going to be using against it, and it defines like ultimately that metadata is probably going to hold the units of like, okay, this is like all the same PDF, or like I want to maybe do it by pages or things like that. And so I think like it starts really with like designing that metadata, and that metadata needs to be designed directly depending on like what the application is. And so in our case, when we're looking at things like encyclopedias, I don't really care about the encyclopedia as a whole that much. The only reason that I might keep the source is because like I want to be able to provide a reference. But outside of the reference, like I don't really care about the whole. I don't even care about the pages. I actually care about sections within it. Um, for us, like I think like the metadata design there starts with, okay, like we're gonna need some type of source because we want to know where it's coming for references. Um, the encyclopedia is structured in a way where the sections kind of hold the information per disease or per like issue essentially, which is ultimately what we want to extract, because the end goal is that we want to be able to say, hey, based on the symptoms, what disease, what issue do you think it might have been? And so being able to structure those sections, I think, then becomes kind of the second thing that we need to capture from a metadata perspective. And then how we actually start to then organize this into vectors and knowledge graphs, I think starts to kind of like depend on what we want to do with the data itself. And so in this case, like we're trying to take symptoms and kind of match them into the problem. And so we might be able to leverage like knowledge graph tuples to be able to have, for example, like symptom to disease like considerations. That said, like I think that in our case that actually doesn't work as well, just because generally a single symptom does not necessarily mean that you're getting that it's like it's necessarily that disease. And so like there might be more of like a one to many relationship between the disease and like the symptoms. And so we have been kind of like thinking about like or experimenting with what it would mean for us to, for example, process those sections into like a vector, for example, that where the actual embedding itself might be the symptoms, like the list of symptoms, and where the value associated to it is actually the disease. And so being able to take, for example, the nodes that we have with the symptoms and comparing them to the symptoms within those nodes. The problem there that we are seeing is that the fidelity is not as high in some cases, just because like it sometimes the the detail in the symptoms matters a lot, and that detail is not necessarily captured as well within the embedding. And so I do think that like we're probably going to end up using some type of combination where we're able to have, I think, on the graph side, much more like precision between the relationships between the entities, but then do have some like probably use the embeddings as maybe as a way to help us filter, like do some initial filtering essentially. um I'm curious if like that's the way that you've also been thinking about it, or if there's a different approach that.
Yeah, I think I'm really liking this kind of like multi-vector approach. Like, and I actually just discussed this with Tangyu Ma, who's a professor at Stanford, who's created a Voyage
Oh
AI,
yeah,
which is
yeah.
embeddings. And this idea of having multiple embeddings with some kind of like uh, prompt that you add to the context. So, and your example of symptoms is just perfect. That's the best example I've ever heard of this, actually, because you could have a like if you describe the sentence of I'd hate to like put a symptom on my dog and making up an examples, but
You can make up a dog. A lot of our tests use Mr. Wiggles. So what
Mr.
does Mr.
Wiggles.
Wiggles have? Mr.
Yeah,
Wiggles has, I don't know, diarrhea or like or something. Yeah.
yeah, something like this, and then you have this prompt of like some information on a suspected disease, and then you have the symptom that results in a different embedding, and you have embeddings per each of the diseases you suspect it to be. I could see that being really powerful. And I mean, the knowledge graph thing, I think with like medical ontologies, that's maybe the most common thing they say, where you're kind of like, it has your dog has this gene mutation, and that mutation is associated has like the edge to this, kind of thing. And yeah, I really like that.
Well,
Yeah,
yeah, like I could think on the graph side, like we if we're able to parse out, because yeah, like I think that the problem with symptoms and graphs is that like the relationship is kind of like fuzzy in a lot of ways. It's like dehydration might be a symptom of like 4 or 5 diseases, and so it's like the fact that the dog is dehydrated does not necessarily give me like a perfect relationship. And so that's where like I think like there might be some interesting like filtering that could be done between embeddings and knowledge graphs, where if we're able to distill down at least you know as close as possible to we, because by the way, with differential diagnosis all we need is a list. So we're not trying to be precise with like a single diagnosis. It's more like we're trying to bring up what are some other possibilities that might have not been explored yet. And so from that perspective, I think that like being able to filter down using embeddings, and then maybe using that and then corroborating that back into a graph where, okay, like based on these ones, like let's like double check essentially like our answer by saying, okay, like we said that it could be gastroenteritis. Is there an edge between gastroenteritis and like this symptom that it has? And it's like, no, there's no edge. Okay, like let's get rid of it, because maybe that was a kind of a false positive that we got out of the embedding, because like maybe most of the symptoms matched, but there was maybe one symptom that did not match. And so I think like knowledge graphs could actually be like almost like a negative filter of being of helping us kind of like double check the work that we're getting out of embeddings and saying like, did we mess up? Like, is there anything in here that we can discard because there's no edge between those two essentially?
Hmm. That's kind of what we also had Professor Laura Dietz on the podcast, and that was kind of her recommendation as well. Is you kind of like retrieve with embeddings, and then you have entity linking within the data, and then you bring it in the graph, and yeah, all that is so powerful. David, thank you so much. I mean, it's been so great. Kind of, I'm just so excited to be keeping along with you and Kevin's entrepreneurial journey and Y
Uh,
Combinator and this new VetRec, and I already get the feeling I'm going to learn a lot about like medical AI from keeping up with your journey and your blog posts. As
yeah.
a quick anchoring question on the podcast is sort of like a generic question I've started asking at the end is, what directions for the future of AI excite you the most?
Um. So right now, I'm most excited. I think about some of the like I think multimodal is still like in infancy, and like I'm getting like more and more excited by the day of like what's happening there. I think particularly as that evolves, I think that it'll become much more democratized, which I think I'm excited for, because I think like to this day, I think like especially with vision, I think it's an area where there's just so much possibility on providing eyes to computers in ways that like can be easy to use, like before OpenCV or whatever, that's like that's like it's pretty hard, and so I think that's probably the place that I'm most excited, and it is an area that we're actively thinking about on VetRec to see how we can bring that in, because it is a question we get a lot from patients. It's like from doctors. It's like you hear what I say, but like, what about what's happening in the room? And it's like, well, I think it would be great if we could detect things there too. So that I think is probably the area that I'm the most excited about, and that it still just feels like it's in the infancy. So.
Mm-hmm. There's a paper on that from Fei Li at Stanford called Ambient Intelligence, and it's kind of like that
Yep.
idea of computer vision always in the hospital. Like,
Yeah. Yeah, we didn't talk too much about like privacy and stuff like that. But it is, I think, like it is gonna be part of kind of that equation of like, how do you make sure people are comfortable with this? Um, and but I think that like the possibilities kind of become a little bit endless from that perspective, because suddenly like I think that the fidelity of information that you have is just so much higher. It's like you're now able to kind of match what's being said with what's being seen. And be able to kind of like combine everything to have like a very crisp and just descriptive like description of what just happened in a place. And I think that that's going to apply to in the medical setting for sure, but I think it's also going to apply to other areas where we today might have transcription and voice, but we don't have video. And I think it'll be a pretty big game changer. So I'm pretty excited about it, and yeah, actively taking a look at how we can start to work with it.
yeah, super, super exciting. That's even how I started with AI and computer science. I came from playing basketball, and I was like, okay, I'm gonna try to build a convolutional network to classify baskets. And it's like I'd like to leave the gym after playing pickup and have like a highlight reel and maybe a text report of how I played, but then I don't want my like air ball to be on the YouTube right away.
Yeah, I mean, like that's awesome. Yeah, I mean, it's I think in the future we're all gonna have like highlight reels of about everything we do, which might be a good or bad thing. I don't know if we want like a highlight reel of everything, but I've always been just generally a proponent of like the idea of almost like over collection of data, because I just find it so interesting, the idea of like having insights on like virtually everything you do, like every action you take, there's like a data point that is associated to it. And like I think that we're kind of finally getting to a point where that, at least from a technical perspective, is becoming a reality. I do think that like the main limitation that we're going to see is just like more from like a privacy and security perspective, to be honest, because yeah, like who wants to be recorded all day and for that data to be somewhere, like so yeah, I think there will be a lot of debate around this, but I'm personally excited about the idea of having like a camera follow me around and tell me tell me about my day and what went well, what didn't go well. It probably would just tell me I'm too stressed or something like that, but it's fine.
Awesome. David, thank you so much for joining the Weaviate podcast. So many exciting ideas. I can't wait to keep up with your entrepreneurial journey. I hope everyone listening follows David and Kevin on Twitter, is in VetRec and LinkedIn, all these platforms to keep up with the story. David, thank you so much.
No, thank you so much, Connor. I'm excited to have been finally part of the podcast, and happy to keep up for sure.